Hey guys, welcome back. So we just finished up our last unit over logic and reasoning, and if I haven't, I will be putting in all those grades shortly. So your grade should go up or go down compared just depending on how you did on the last unit. So I'm no longer accepting any homework from Unit 2 unless I spoke to you about special arrangements. Some of you guys were sick or things like that, which got you behind. So anyway, if you've spoken with me, then that's okay. You can keep moving on where you are, but everyone else, we're all starting the next unit together. So even if you didn't finish some of your homework assignments from Unit 2, you need to take that test ASAP, and we're going to move on to Unit 3 together. So Unit 3 is over parallel and perpendicular lines, and we'll get into that in just a moment. So first, let's look at how we did on the last test. Believe it or not, we're actually doing fairly comparable to how I did last year with my students. And so even though you guys are doing distance learning, you're doing fairly well. So good job. I'm impressed. This is the average for mastery. So mastery is like getting about 75% of that standard of those questions over that standard correct. So it's kind of where we want to be. So it looks like for you can see the hour breakdown here per standard, but the overall mastery average, you see that seventh hour actually had the highest percent of mastery, and followed by first hour, and then fourth hour, then lastly third hour. So you guys are doing all right. I've got a lot of things going through my mind about how we're going to do things for the rest of the year, kind of contingency plans, and if I'll let you guys do retakes if we come back in person, I think we'll be able to have time to do that. I think that's probably the best way to do this moving forward. But there's a lot of things that are still up in the air. We're still trying to figure out how we're going to do certain things, but that's okay. I'll definitely make sure I give you guys an opportunity to get your grades up. However, I decide that best looks or whatever we can do depending on just kind of the schedule and what it's like to do a block schedule, because it's totally new. Anyway, so I won't bore you with anything of any other of my thoughts. Let's go ahead and get moving with the new stuff today. So the name of the unit is parallel and perpendicular lines. Primarily, we're dealing with parallel lines. So we do need to define these and show you some symbols. So parallel lines, the symbol for that is just two vertical lines here. They're usually oversized, so notice they're not just an L, it's a little bit larger than that. But these are parallel lines. They're non-intersecting coplanar lines. So the coplanar means that it's on the same plane, and they're lines on the same plane. So for instance, if we have this line GH, parallel to GH would be CD, because they're on the same plane and they don't intersect. So they're on this right surface here. We could also do FE. That's also parallel to GH because it does not intersect and it's on the same plane, the bottom one. We could also do AB. So AB, there's actually a diagonal plane going from A, H, G, and B. So if you can imagine a diagonal plane cutting across there. So AB is also parallel to GH because it's coplanar and they do not intersect. So those are all parallel lines. Those are the only four parallel lines that we could form that are parallel to GH. So those are parallel. Let me back up just a little bit. Now the next one is skew. So skew is non-intersecting, just like parallel. There's no special symbol for it, by the way, but they're non-coplanar. So instead of having to be on the same plane, they're not on the same plane. So essentially what we do is we take parallel lines and then we twist one of them, and now they're no longer on the same plane. So let me show you a few skew lines here. So here are two. Here are a pair of skew lines. Now these two themselves are parallel to each other, but they're skewed to the red line. So we're kind of referencing from here. So notice that the green lines do not intersect the red line. Okay, they're also not on the same plane. So they're not on this far right surface. One of them is on the front surface or the top surface, however you want to look at it, but they're not on the same plane. There is not a plane that goes through the green and any one of the green lines or the red line. So those are skew lines. We also have these two back here, which again, pairwise are parallel, but they are skewed to the red one, right? They don't intersect the red line, even if they kept extending forever. They're on different planes as well, so they're not parallel. We have a few more we could also do. Okay, so it's kind of interesting. We could cross these two here. There's still neither of those are going to intersect the red line. Neither are they going to be on any of the same planes. I got one more example I'm going to show you here of skew lines. So lots and lots of skew lines. I could actually move some of the other ones out of the way if I wanted to. But anyway, those on the very top there, those are going to be skew as well because they are not parallel, I'm sorry. they're not on the same plane as the red line, and they also do not intersect the red line. They keep going forever. You can see it's just twisted, right? So they would be from parallel to being twisted, as you can see there. Okay, so those are skew lines. Then after skew, we have perpendicular lines. So perpendicular are pretty simple. They have this symbol here. It's just like an upside down T, but it's not quite a T. Anyway, that's a symbol for perpendicular lines, which, I mean, parallel lines is just two lines going straight up and down. Perpendicular shows perpendicular lines. So these are lines that intersect at a right angle. So pretty much all these lines that intersect at a right angle, at least when we're dealing with a cube. So line AB intersects line AD at a right angle, so they're perpendicular. AE is perpendicular to AB, they're intersecting at a right angle, etc., etc. All right, then the only other one, which is a new word that I really usually don't even teach this word, but I added it this year because it's kind of fun, is orthogonal. So orthogonal, instead of two lines being perpendicular, orthogonal is when a line is orthogonal to a plane when it forms a right angle with the plane. So when we have two lines that intersect, that would be, let me show like these two. Yeah, so these are two lines that are going to intersect forming a right angle, but orthogonal means that it's going to form a right angle with a plane. So let me give you an example of that. So here we have a plane on the bottom, okay, this bottom plane here, and each one of these blue lines is orthogonal to that plane, okay? So instead of intersecting two lines to be a right angle, if we have a flat surface, orthogonal means that it's going to be perpendicular even as we rotate it in all directions. It's going to be perpendicular to a plane instead of just to a line. So if we looked at two lines like the red line and the blue line, those two are perpendicular, but if we compared the blue line to the plane, which of course extends forever, and if we could show that, so the arrow is going on forever, I just show it representing a face on the cube here, that would be orthogonal. So new word, kind of fun, thought I'd show it to you. So parallel, skew, perpendicular, or orthogonal, those are the words you need to know. So which line is the steepest, and how do we measure steepness of a line? So if we look here, we have the blue line, the green line, and the red line. Which one is the steepest? Well, it looks like the steepest is AD, right? The red one, then the green one's in the middle, and the least steep one, or the shallowest line, would be AB. But how do we measure the steepness of an angle, or not an angle, but the steepness of a segment or a line? Well, that's done by the slope, if you remember. So how do we measure the steepness of this slope here? We do rise over run. So it looks like we're going up 1, but we're going over 4. So this would be 1/4. For AC, it looks like we're going up 2 and over 2. So that's going to be 2 over 2, which of course this can be reduced to just 1. And we will reduce all of our fractions. And then AD is going to go up 3 and over 1. So that's going to be 3 over 1, which of course reduces just to be equal to 3. So which one is the steepest? Well, the one with the steepest slope is the biggest number, which would be AD, with a slope of 3. And then 1 would be AC, the next steepest, and the most shallow would be the proper fraction of 1/4. All right, then we have two special case, which maybe you've heard of Hoy-Vux before. I should have learned it last year in algebra. But anyway, Hoy-Vux tells us what happens when we have horizontal lines and vertical lines. So these two are special cases. And so usually we remember Hoy-Vux in order to remember what's going on here. So here we have a horizontal line, which is the blue line, and a vertical line, which is the red line here. So CB has what is its slope? So how much is it rising as it goes from point C to point B? Well, it's rising 0, and it's running 3. So rise over run would be 0 over 3. If we take 0 and we divide it by 3, it's just going to be equal to 0, right? If you have nothing and you divide it evenly into 3 people, you still have nothing, right? You give everyone equally nothing. All right, let's go ahead and do, well, yeah, I guess I'll go ahead and define it. So Hoy stands for horizontal line, which we have, that's the blue one here, is the slope of 0 is what the O stands for, and then Y. So the Y is telling you that's how you define the equation. So what we have here is y is equal to 1 is going to be the equation for this line. So another way of reading that, because usually y is going to change as a variable x changes, but in this case, regardless of what value x is, it doesn't matter if like we had on C, when x was 1, y was still 1. Whenever x was 4 for B, y was still 1. So for all values of x, regardless of what the x is, the value of y is always going to be equal to 1. So that's why it's a constant. So this is how we would read that equation. So for all values of x, regardless of what x is, that's an upside down a is a quantifier all. Okay, so for all values of x, comma, y is always equal to 1. So regardless of what you tell me what x is, I know y will always be 1. So if x is 7, y is 1. If x is 10, y is 1. If x is 100 million, y is still 1. It doesn't matter. All right, so what about for AD? Now we're dealing with a vertical line, just going straight up and down. The slope is increasing by 2, but we're not running any, so it's going to be 2 divided by 0. But what happens when you divide something by 0? It's undefined, right? You can't divide anything by 0. Even thinking about it should hurt your brain if you really know what division's all about. Like, can you divide something into half? Yes. Can you divide something into 1? Yes. Can you divide something into 0? What does that even look like? It hurts my brain, right? So we would call that in mathematics an undefined slope. Okay, so we can't divide by 0, so that would be an undefined slope. So in this case, if it's a vertical line, our slope is undefined. So that's what the VUX stands for, vertical line, undefined slope, and x, meaning we would define this line as x is equal to, and in this case, x is equal to 6. So again, just like we did for all values of x, y is equal to 1, now for all values of y, regardless of what y is going to be equal to, x is always going to remain 6. So when y is 5, x is 6. When y is 4, x is still 6. When y is 3, it's still 6. 2, still 6. 1, still 6. Doesn't matter what values of y we have, x will always be equal to 6. So for all values of y, x is equal to 6. Again, usually we would write y as an equation using a variable of x, but in this case our y is constant, so we simply state that x is always going to be equal to 6, regardless of what value of y we have. Alright, so that's again an upside down quantifier a, which will tell us for all values of y, x is equal to 6. Let's do some more slope here. So on this one, we want to find the slope of AB. So our rise here is going to be positive 3. So we're going up 3. Our run is 2. So that's going to be slope of 3 halves. Here, looks like we're going over from -4 to 1, which is going to be 5. And then we're going down 3. So notice our slope is going to be negative because we're going down, right? So that's going to be a slope of -3 over 5 because we do rise over run. So -3 over 5, somewhere in here, yeah, -3 over 5. And then on this one, looks like we're going up 3, and we're running from 1 to 5, which would be 4. So it's 3 over 4, or just simply 3/4. All right, that's it. So our equation for a slope is the rise over the run. The rise is defined as the change in the y. The delta just means the difference. We use the capital D delta in physics to tell us the change in some value. So this is the delta y, the change in y over the change in x. So how far are we going up over how far are we going to the right or to the left? So it would be positive or negative depending on how we do it. All right, so looking at slope formula, the slope formula you should be familiar with, and it will be on your assignment, is y2 minus y1, which is the difference in the y's, or otherwise known as delta y, over the y2 minus x2 minus x1, which is the delta x, or how far we're running. So rise over run. So in this case, if we have our points A and B, we're going to call this one our first point, and this will be our second one. So this is our x1, y1, and this is our x2 and our y2. Okay, so if we do y2 minus y1, that's going to be 3 minus 1 over 6 minus 2, which is going to be, that's 3 minus 1 is 2, and then 6 minus 2 is 4. And of course, we can reduce that just simply to 1/2. So this has a slope of 1/2. Now, what would happen if we switch the order of the x's and the y's, or we switch the order of the pairs? That's totally fine. So instead of y2 minus y1, we'll do y1 minus y2. The reason they usually do y2 minus y1 is because we are assuming that the value of the second one is going to be bigger than the smaller one, and this will help us not have as many negatives, at least if we're in the first quadrant. It's kind of how that works. So y1 minus y2 would just be doing this backwards. That would be, so y1 minus y2 is 1 minus 3. And then we would have 2 minus 6. So 1 minus 3 is a negative 2, and 2 minus 6 is a negative 4. But when we have a negative over a negative, it becomes positive. So we're left with simply 1/2, which is exactly the same thing we got up here. So if you do flip them, just make sure you do it in the same order. So if you do y2 minus y1, x2 minus x1, or do y1 minus y2, and then x1 minus x2. So it doesn't matter which way you do it, you'll get the exact same answer. Another thing, whenever you're graphing it out, if you're doing it visually here, you can do your rise of 2, your run of 4, or you can go from the right point to the left point. So now we're going down 2 and we're going to the left 4. It's the same thing as you see here, right? So rise 2, run, so that's going to be 2 over 4, which is 1/2. Or we can do rise of negative 2 and run of negative 4, which would give us the same 1/2 slope. So it doesn't matter if you go from the left to the right or the right to the left, you'll get the exact same answer. All right, so the next things we want to talk about is parallel lines. And so if we look at these 3 lines, we have the red, the green, and the blue. Which 2 are parallel, if any, and how do we know? So parallel lines mean that if they're all coplane, they're on the same Cartesian plane, so they're not skew lines. So if they are going to intersect, if they're either parallel or they're going to intersect, they can't be skew in this case because they're all on the same Cartesian plane. So on this one, clearly the red is going to intersect the green and the blue. If we extend these on forever, they will intersect here. The other one's going to intersect further on down the line. So how do we know if they're parallel? Well, let's look at their slopes. So this one is a horizontal line. So it's going to be, so Hoy Vux, so H-O-Y. So y is equal to 4. For all values of x, y is equal to 4, and it has a slope of 0. For CD, it looks like we're rising 1 and we're running 4. I'm going to graph these out here real quick so you can see it. So that's going to be a slope of 1/4. And then for AB, you're going to notice that it's going to do the exact same thing. It's going to rise 1 and run 4 as well. So because these two have the same slope, that means they have to be parallel. What that means is for every time we rise 1, we're going to run 4. And the next time, we're also going to rise 1 and run 4 again. All right, this is actually really cool. So same thing, and the same thing is going to happen here. We rise 1, run 4, and so if we do that again to the next point, we're going to rise 1 and run 4 again. So, and then the next time we do it, we're going to have the same outcome, right? And the same thing over and over and over again. So will those lines ever intersect? No, because they are rising and running at the exact same rate, which means as long as they're not starting in the same point, which would look something along the lines of this, if they start at the same point, they would of course intersect, and they would intersect infinitely many times because they're not unique lines. They're the same line, right? But as long as they're starting at a different point, that's not collinear, they will never intersect because they rise and run at the exact same rate. So parallel lines have the exact same slope, is what you need to know. So are these 2 lines parallel? Well, it's kind of hard to tell, but once we figure out their slopes, we can tell. We can confirm whether or not they will intersect because we don't know. They could be really close, but we can't necessarily extend them on forever. Wait, maybe actually I can. I can extend them forever or close to forever, but you can't see. They still won't intersect, or at least they haven't intersected yet. But can we prove that in Cartesian geometry they will intersect at some point? Yes, by looking at their slopes. So we're going down 2 and over 3. So that's a slope of negative 2/3. Here we're going down 2, but we're going over 4. So those are not quite the same. They're close, but not the same. And we can see that when I graph the points here for the components. So this is over 3 down 2. And if we did over 3 and down 2, it's going to go to this point instead of this one here. So clearly they will intersect because they're not rising and running at the same rate. Okay. All right, so what about perpendicular? So parallel lines have the same slope. What about slopes of perpendicular lines? So perpendicular lines here are lines that form a right angle. One of them has a slope of 1, the other one has a slope of -1. So if we look at this right now and we try to make a conjecture, you might say that what makes lines the slopes of perpendicular lines would be the opposite of each other. So then if we had a slope of +2, that should be perpendicular to a slope of -2. So that might be what you're thinking so far. But let me go ahead and rotate this to another set of points we have here. So here we have the second set of perpendicular points. And let's look at their slopes. So AC, from A all the way to C, looks like we're going over 5 and up 3. So rise or run would be 3 over 5. So this would be 3 over 5. Okay, 3/5. And then over here, it looks like we're going down 5 and over 3. So that's going to be -5/3. thirds. So if you notice here, the difference between the two is just it was the opposite, right? So +1 to -1. But here, now we're going from 5/3 to -5/3. So it's not just that we're changing it from a positive sign to a negative, something else is going on. Can you see what's going on? So if we move the points to a next one, another set of perpendicular lines here, we can evaluate their slopes as well. So for AC, it looks like we're rising 2 and running 5, so that's going to be 2/5. And then from B to C, we're going down 5, and then we're going over 2. So again, we're not just going from positive to negative, we're doing something else. In fact, you can probably see it here and now, as that we're actually changing, we're doing the reciprocal. So this is called the opposite reciprocal because it has the opposite sign from positive to negative, and it's the reciprocal because we're switching the numerator and the denominator. The reason you couldn't see it with the 1 and the 1 is when we switch the order of the 1 and the 1, it's still 1 and 1. But here we went from positive to negative, and we switched the order of 3/5 to 5/3. Here we went from +2 to negative, and from 2/5 to 5/2. So it's called the opposite reciprocal. You can see the pattern again here. We switched the order of 3 and 5 to 5/3, and we changed the sign from a positive to a negative. Same thing here, we go difference from 2/5 to now 5/2, and we change the sign from a positive to a negative. And this is called the opposite reciprocal. So I'll graph these out next to each other so you can see what's going on. We are switching the order from 3/5 and to 5/3, and then changing the sign from positive to negative, and the same thing here. And by the way, you would do the same thing if you were just going back and forth from in both directions as well. And it's called the opposite because we changed the sign to be opposite, and a reciprocal because we switched the order. So here it is kind of in general form. AB would now be -B over A. We have the opposite sign, and the reciprocal switches the order of the numerator and the denominator. All right, the other thing we need to remember is slope-intercept form. So slope-intercept form is y is equal to mx plus b, where m stands for the slope. That should be different. And b stands for the intercept. So that would be the y-intercept in this case. So that's where it crosses the y-axis. Hopefully you remember how to graph lines. That's what we're going to be doing. All right, so here's our equation. Y is equal to 7/5 x minus 4. So what is the slope? Now it's already in y is equal to mx plus b form. First thing we notice is that there's no coefficient in front of m. If there was, we'd have to divide it. Also, the x term is on the other side like it's supposed to be, and we're good. So because it's in y is equal to mx plus b form, that means the 7/5 has to be our slope, and the -4 has to be our y-intercept. So pretty simple, easy. All right, that's it. So let's get going with the assignment. So on number 1, we want to name a plane that is parallel. Should just be a plane. Fix that. So a plane that's parallel to QUW. So if we look at QUW, let me change colors. That's going to be, so here's point Q, here's point U, and here's point W. Now S is also going to be on that plane, but to define a plane you only have to use 3 non-collinear points. So we're talking about this plane, which is going to be this left surface over here. So we have this left surface, and we want to know a plane that's parallel to it. So parallel would be the plane, that's so cool, that is on the opposite side of it, which again, all 4 points go through that plane, or are on that plane. We only have to name 3 of them. So we could call this plane TRV. You could also call it RVX or TXV. It doesn't really matter. Just pick 3 of them as long as they're not on the same line. If they were collinear, then it would be not well defined because it'd be allowed to rotate 360 degrees, right? Okay, so what about 4 lines that are skewed to WX? So let me go ahead and get rid of this stuff here. All right, so WX is going to be this line right here. And in fact, I can just use my line tool so it'll look cleaner. Yeah, we'll do green, that's fine. All right, so here's WX. That's a segment, but you get the idea. All right, so we want 4 lines that are skew to that. So skew means that they are not intersecting, but they're also not on the same plane. So I couldn't do ST because ST would be parallel with WX. So if I do ST, but then I'll need to twist it. So instead I could do SQ. So those are not going to intersect and they're not on the same plane. So likewise I could do TR. I'm going to have to fix that one real quick. So here is TR. We could also do, let me see, we could also do QU. So in the back here, could do QU. So likewise, I could do RV as well. Now there are others, like you could do TV going across here. That was pretty terrible. There we go. Likewise, we could also do SU as well. So there's technically 6, but just give me 4 of them. They do not intersect, and they are on different planes. In fact, this one looks like it goes over the top, but it actually goes over the back. So I'll bring that one up to the front, because aesthetically that is actually correct on the intersection there. Otherwise, it's not true. All right, so just give me a name of 4 of those that are skew. All right, a plane EF, it wants to know true or false. Plane EFB is going to be parallel. That's what this symbol means. The 2 lines that don't intersect, parallel to plane ADB. So EFB, so EFB, okay, so that's going to be these 3 points here, E, F, and B. So we're obviously talking about the surface on the bottom, right? Which C would also be a part of that plane. So we have this plane here, EFB, is going to be parallel to plane ABD. Now, if you notice, there's not going to be any ones that are parallel to this one. If there was, I guess I'll do that side. It would actually be over the top, right? So there's not going to be any of them that are parallel. They're all going to intersect. The other one they were saying was plane ABD. So ABD. Okay, so A is this point here, B is this point here, D is this point. So we're obviously talking about the front surface. That would include E as well. So those 2 planes are going to intersect, and their intersection is going to form the line BE. So this is false. They're not parallel. They intersect, and they intersect forming line BD, which is actually kind of similar to a test problem that was the most missed problem. By the way, when you have 2 planes that intersect, they intersect to form a line. That's actually a true statement. All right, then we have these 2 lines, and they want to know if they're skew lines. So we have FE. I guess I'll... That's one way to clear it out. All right, so FE is going to be this line back here, and then AD. So FE is this line here, and then AD is the line up on the top. Are those 2 skew? So do they intersect? No. Are they parallel? Which means, are they on the same plane? Well, no, because AD is on the front surface, but F or EF is on this back surface. So they're not going to be on the same plane. So this is a true statement because they are skew. They're non-coplanar, and they do not intersect. All right, number 12, your friend says that the sides of a ladder and the rungs of the ladder, wow, don't know why I couldn't read that, which are also known as the steps, are skew. So the only problem with that is that they actually intersect, and they should intersect at a right angle. So instead of being skew, they should actually be perpendicular, which is that symbol right there. So the reason that we can say that they're not skew is because they intersect, right? So they can't be skew because skew and they're on the same plane, right? All right, 2. If 2 planes are parallel, then all the lines within those planes must be parallel. So here we have this plane on the bottom. Here's all the lines that we could make, at least with those 4 points. All right, here's a parallel plane, which is on the top surface here. And here are all the lines, possible lines that could be on that parallel plane. Now, is it true that any one line from the red plane or whatever, the red lines, are going to be parallel to a line on the blue plane? So this is interesting because if for any line that we have on the bottom, there would be one line that would be parallel on the top, but the rest of them would all be skew because they would be twisted. So if we looked at CD, CD would be parallel to GH, okay, but all the other lines would be twisted, rotations. They're non-coplanar, so they would all be skew. So this is not necessarily true. If we restated this instead of all lines within those planes must be parallel, and we allowed it to be parallel or skew, then the statement would be true. Another way of just saying it is that they do not intersect. Wow, can you imagine if you had to wait for me to write everything down, how long these videos would take? There's a reason I do things the way I do. So anyway, hopefully you understand that. They don't intersect, but they're not always necessarily parallel. They could be skew. Or rewrite the equation in slope-intercept form, which is y is equal to mx b, if necessary, then determine whether the lines are parallel, perpendicular, or neither. We're going to be able to tell that by the slope. So if they're parallel, that means they have the same slope. If they're perpendicular, it means they have opposite reciprocal slopes. And if they're neither, then it's just something else. So the first one's already y by itself. there's no coefficient in front of it, and there's no x term with it either. So this is already in slope-intercept form, meaning the slope of this line has to be whatever's in front of the x, which is an understood 1. So this has a slope of m is equal to 1. We might do m sub 1. Now in the second equation here, it's not in y-intercept form yet because the y is not by itself. First thing we need to do is move the x term over. So I'm going to subtract x from both sides. Now I can't do 4 minus x because they're not like terms. This doesn't have an x with it, so that's not going to be 3 or 3x or anything like that. Instead, we're just going to put them next to each other. So we have negative 2y is equal to negative x plus 4. There we go. All right, now I still don't have this in y is equal to mx plus b form because the y is not by itself. It has this coefficient of negative 2. So how do you undo multiplication of negative 2? Well, we're going to undo it with division of negative 2. So we're going to divide all the terms by negative 2. Technically, we're dividing both sides by negative 2. We're going to go ahead and distribute that through using distributive property to both of the terms. So just divide all the terms by negative 2. When we do that, that's going to divide to 1, leaving us with y, which is what we want. And then we're going to have negative and negative. When we divide a negative by a negative, it becomes positive. And then 1 divided by 2 is just going to be 1/2. So that's going to be 1/2 x. And then 4 divided by negative 2, there's 1 negative, so it comes in front. So it's going to be minus 4 divided by 2, which is 2. All right, so now that we have this in y-intercept form, y is equal to mx plus b, whatever is in front of the x has to be our slope. So over here we have a slope of 1, and over here we have a slope of 1/2. Now, these are not opposite reciprocals. They're not opposite. They're also not the same slope. So they're not parallel and they're not perpendicular. So the answer to this one would be neither. You'll get 15, kind of the same problem. Already in slope-intercept form, meaning we have a slope of negative 3. Then over here, we got to do some rearranging. We want to get the y by itself, so we're going to subtract 12x for both sides. We're left with 4y is equal to 12x minus 24. Then I want to divide everything by 4 to get the y by itself. When I do that, I get y is equal to 3x minus 8. So then over here, we have a slope of 3. So we have 3 and negative 3. Now those two are opposite slopes, but they're not reciprocals because we didn't switch the order. What would the opposite reciprocal of negative 3 be? Now remember, the negative 3 is technically negative 3 over 1. So when I do the reciprocal of that, it's going to be a positive 1/3. So if they were perpendicular, it would be positive 1/3, like and negative 3. But they're not. They're just opposites, not the opposite reciprocal. And they're not the same slope either because they're opposites. So this would be neither again. They're neither parallel nor are they perpendicular, or they just intersect, but they don't intersect at a right angle. All right, look at number 20. So find the slopes to the lines, slope of line 1 and slope of line 2. So that's what the sub 1 and sub 2 are. You can also see them. They're kind of hard to see, but they're there. So anyway, find the slopes and then determine if they're parallel. So if they're parallel, we know that they have the same slope. All right, so for line, the first line here, we're going to do, you can actually just count if you want. So we're going down 1, 2, 3, 4, 5, and we're going over 2. Okay, so that's going to be a rise of negative 5 over 2. You could also use the points. So negative 2 minus 3, and then negative 2 minus 4, negative 4. So when we do minus a negative, it becomes plus a positive. So negative 2 minus 3 is going to be negative 5, and then 2 plus 4 is going to be positive 2. So our answer, or slope, would be negative 5/2. So go ahead and write that out. And then for the slope of the second one, we're going down 1, 2, 3, 4, and over 2. So that's going to be 4/2. You can do it that way as well. So negative 4/2. Notice they're very close, but they're not the same, which means they are not parallel. So determine if they're parallel. And if our symbol for parallel is 2 lines going straight over it, we could cross the line out like that, and that would be the symbol for not parallel. All right, 24, similar. We want to find the slope of the line, then write an equation and graph another line that's parallel to the given line. So first we want to find the slope. So graph 2 points that are intersecting exactly on the integer solutions or linear Diophantine solutions. Fun words that I know what they means. So basically find 2 that meet on the crosshairs perfectly, like this point and this point. We're rising 2 and we're going over 1. So that's going to be a slope of 2. Okay, so our slope should have something. Yeah, okay, anyway. So you could also graph the points and do it that way. But anyway, we get a slope of 2. Man, really struggling today. All right, so if we want to write the equation of a line that's parallel to it, it's also going to have the same slope. So just write y is equal to 2x, and then you can really add any b to it. That part doesn't really matter. So if I graph 2x plus 2, if I start out at the point 2 here, okay, and then I go up 2 and over 1, up 2 over 1, down to left 1, down to left 1, you'll notice those two are going to have the exact same rate of change, the exact same slope, and so they'll never intersect and they'll be parallel. So also, if you notice, it doesn't matter if I change this to plus 3 instead of plus 2, we're going to get the another line that's also parallel. So instead, if I did plus 3, or if I did plus 0, which would be just kind of leaving that whole term off altogether, it's still going to be parallel, as long as it's something different than the slope that we have for this one. Then it will be the same line, right? So we just need to make sure that it has a different b to it. So you can do plus 1 or minus 1, you can do minus 3, minus 4, doesn't really matter. You can do it however you want. So anyway, you notice that they're going to be the same rate of change because they're rising and running at the same rate. All right, 26 wants to do the same thing, but now we want to write another line that's perpendicular. So that means it's going to have an opposite reciprocal slope. So first find this slope. Looks like we're going down 2 and over 3. So we can write our rise and our run. So that's going to be, if we actually graph the points themselves, you get 2/3. So the opposite reciprocal of 2/3. So what we're going to do is we're going to change the sign from a positive to a negative, and we're going to switch the order. So 2/3 is now going to become 3/2. So when I write the equation, I'm going to do y is equal to negative 3/2 x plus some value. I'm just sticking with 2 because it's kind of fun. So if I started out at the point 2 here, I'm going to graph this out because it's kind of fun. So graph it out starting at 2. I guess I should change the color. So starting at 2, and then I'm going to do a slope of, it should be negative 3/2. I forgot to change it. Okay, so that should be negative 3/2. So I'm going to go down 3 and then over 2. What? No, this is actually negative. I'm sorry. So this is technically negative, so this one should be positive. I just forgot to write the negative up there. So I did have this correct. But this should be in, yeah, so this should be positive 3/2. All right, so anyway, I'm going to go up 3 and then over 2. Yeah, that looks a lot better. Down 3, left 2. And if I connect the line going between those, which I've already done, because that's how I roll, you'll notice that it will actually indeed be perpendicular. Now, if I do plus 2, that's one way of doing it. We could change this to go through the origin at 0, or we could even do negative 2 or any other value. Notice that it'll always intersect here at a right angle. So I'm just going to go across the whole thing. That is always going to intersect at a right angle, which is like so beautiful. Anyway, so that's it. I'm going to go ahead and call it quits. Sorry that took some time. It will not take anywhere near as long to go over this again tomorrow because I won't have to reteach the whole thing. So tomorrow's video will be a lot shorter. I'm sorry. My voice is very raspy for some reason today. It's not the audio quality, it's just me. So see you guys. I hope you have a good day.